Hi everyone, welcome to this really short video on ionic bonding. So this is C2, ionic bonding. I'm just going to talk through what ions are and what's ionic bonding. So ions are charged particles. So charged meaning they're either positive or negative. So for example, O2 minus or Li plus, those are both charged particles. It's not always just 1 plus or 1 minus, it could be 2 minus, it could be 3 minus. It just depends what group the element is in. So if I just show you the periodic table. So the group number tells you how many electrons are in the outermost shell. So if you remember back, the 288 rule, so if I just take lithium, I'll just pull it back, lithium has 3 electrons. It's in group 1, so that means lithium will have 1 electron in its outermost shell. So if I just draw that for you quickly, so 288 rule, 2 in the first shell, 1 left over goes in the outermost shell. So there we go, lithium has 1 electron in the outermost shell. So lithium has 1 electron to lose. It's easier for this element to lose 1 electron than to gain 7. Because the idea is to try and get a full outer shell. That's how elements are stable. So it can either lose that 1 or gain 7 extra. And in terms of energy, it's easier just to lose the 1. So if we're losing electrons, if we're losing negativity, that means the element becomes more positive. And that's something you have to get your head round. If you're losing electrons, if you're losing negativity, the element becomes more positive. So for example, how about sodium? Sodium is in group 1. Therefore, again, it has 1 electron in its outermost shell. So the charge will be +1 or just plus, you don't have to put the 1. Let's look at magnesium. Magnesium is in group 2, which means it will have 2 electrons in its outermost shell. Again, it's easier to lose those 2 than to gain 6. So the charge is 2 plus. Now on the other end, in group 7 or group 6, for instance, fluorine has 9 electrons. So if I just quickly draw the 288 rule for you, 9 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, it's easier for fluorine to gain an extra 1 than to lose all 7. So fluorine can gain an extra electron and will have an F minus charge. If we're gaining electrons, we're gaining negativity. So let's move on to ionic bonding. So you need to know this definition. Often comes up in exams, so it's just one to learn. So add it to your little glossary if you've started one. So ionic bonding is the electrostatic attraction between oppositely charged particles. And I'll explain what that means. Electrostatic attraction between oppositely charged particles. So it just means if you've got a positive charge, it's attracted to a negative charge. You know that from magnets. Positive and negatives attract, opposites attract. That is electrostatic attraction. So let's show the ionic bonding for the compound magnesium chloride, MgCl2. So how you do this is you draw the 288 rule for all the elements involved. So I've got Mg and I've got 2 Cl, so I'm going to draw them separately. So Mg, if I look on the periodic table, has 12 electrons. I'm only going to draw the outermost shell electrons, and you can do this too because it just gets messy if you're constantly drawing all the shells. So I'm only going to draw the outermost shell. Magnesium is in group 2, so it has 2 electrons in its outermost shell. Chlorine is in group 7, so it has 7 in its outermost shell. So ionic bonding is the giving and receiving of electrons. That's really important. The giving and receiving, or can't spell. Of electrons. So the idea is to get these elements to a full outer shell. Magnesium has 2 in its outermost shell. It's easier for magnesium to lose those 2 than to gain 6. Chlorine has 7 in its outermost shell. It can gain 1 in order to form 8 and be stable. So it can get that 1 from magnesium. And what you do is you just draw an arrow to show the electron transfer. So just be careful where you put your arrow head. Make sure it's touching the orbital and make sure it's in the right direction. This electron goes to this chlorine here, again, electron transferring. Then what you do is you draw the ionic structures. So ionic structures include square brackets and a charge. So magnesium, we just saw, lost 2 electrons. So what you do is you draw square brackets, this is for an ion, square brackets and the charge in the corner. So magnesium, if it's lost 2 electrons, has a 2+ charge. Chlorine has just gained 1 electron. So the charge is -1, or just negative. It's 2 Cls and they both gained 1. So this attraction here between positive and negative is the electrostatic attraction between oppositely charged particles, and that effectively is ionic bonding. The positive attracted to the negative, and it's all about the losing and gaining of electrons. So let me just quickly run through one more example with you. Let's do magnesium oxide. So magnesium, again, 2 electrons in its outermost shell. Oxygen has, if I just check on the periodic table, it's in group 6. So this magnesium can give 2 electrons to the oxygen. So magnesium will have a full outer shell and have a 2+ charge, and oxygen will have gained 2 electrons and therefore have a 2 negative charge. And this is the electrostatic attraction in this compound. Okay, and that's it for this video. Thanks for watching.